Welcome. My name is Marco and thank you for being here with me. Today I'm going to show you what our system, Liquid Blade 3D, is and how you can use it to etch and engrave metals on your desk. Liquid Blade 3D is an add-on right now mounted on an Ender 3D printer made of a control box, this one, of a pump down there, and some hardware that you place on your 3D printer after removing the extruder. Notice the transformation is fully reversible. You can remove this system and go back to your 3D printer if you so desire. So this is Liquid Blade 3D, and what is it? It's an electrochemical etching system. It's nothing really new if you want. There is a solution, electrolyte, we are going to discuss it in a moment, that is jetted onto the surface, and then with the current going through, you obtain an etch. The control occurs through a web page, so that's all you need from your computer, hosted on the controller. So we start initializing the system, but that's like a normal 3D printer. It goes to home and then it will go to a standard position on top on the workpiece. In this case, the workpiece is a circuit board, a blank of a printed circuit board. Standard one you can buy on Amazon. So it's plastic with a layer of 65 micron of metal, I think. So right now the system initializes. It will go somewhere on top of the workpiece. Once you have done this from the software, you can select a file in G-code format to print. Actually, you can build your own file, that's why the system is useful. The software allows you to translate standard Gerber files into G-code ready for the system, and also SVG's file, those generated by Inkscape or Adobe Illustrator. So once the system is in a stable position, you can select the file. Well, again, you can transform the file in the software, then you can select it. We'll just print a simple circle today, and then initiate print. Now the pump will start and a jet will form. It's quite difficult to see, but here there is a jet of liquid coming out of the nozzle. Initially the pump will pump for 30 seconds and then the current will start the etching. A disclaimer: this system works and can be used for etching, engraving and cutting metals, but it's still a prototype. It works perfectly, but there are many things that can be improved, from cables to the user interface. See, now it's moving to the initial position, and now it will start etching. You can control how the process runs from the main page. Right now there is a current of 40 milliampere running through that jet and etching the metal. So the process seems to, there is a small black line forming behind the nozzle. You will see it in a while. Back to the description. So it's a prototype and we are going to improve many things. If you subscribe to our campaign, you also will tell us what you think can be improved, and we will work on it together. And in any case, we'll show you what we are doing on the system. We are asking you to participate to our campaign, to enter in a production phase, and to develop further iteration of this system and the future evolution of which I'm going to talk in a moment. So, while the etching occurs, let's talk about what is happening. As I told you, there is a small liquid jet, in this case is like 0.2 millimeter in diameter, being pushed by the pump onto the workpiece. The jet is connected to a negative electrode through here and this titanium barrel, and the workpiece is connected through this back connector to the positive. The generator is continuously generating a current, a constant current. We are not controlling the voltage, we are controlling the current. Because in electrolysis, in all etching process, what counts is the current. You want it to be constant. So if you are a little bit farther, a little bit closer, it doesn't really matter. The system will stabilize the current. And when the jet hits the copper, again, the jet is negatively charged if you want, and the plate is positively charged, the copper is oxidized. It's oxidized to, well, copper chloride probably, and immediately this one changes to copper hydroxide. and precipitates as a greenish dust back in the tank. The liquid intake on the back of the system has a filter so that the dust doesn't clog the nozzle. Eventually you can filter out the dust and you remain with insoluble copper hydroxide that you can even recover. What else at this point? Yes, the print is occurring by itself. The system can generate, again, arbitrary patterns. And the dark line that now you should see here is where the etching is occurring. I prefer to do a double pass because in this way, small imperfections that could occur during an etching are averaged out the second passage. So, can we etch only copper? Not really. I mean, you find a lot of video on YouTube about using salted water etching for engraving metal, like steel or signal. Yeah, you can do it with this machine as well. You can even etch, engrave, or cut large different metals like titanium, gold, and so on. But for those, you will need a different solution. Oh yes, the solution, I didn't tell you. It's simply salted water. Table salt, 180 grams per liter in water, tap water or deionized water. We'll add a small quantity of surfactant. We use a organic and biocompatible surfactant called 20, and a few grams of borax to stabilize the pH of the solution during the process. So, copper gets oxidized, or whatever, in this case it's copper, and falls back in the form of insoluble hydroxide. Well, that's pretty much it. The solution is benign. You don't want to drink it because anyway it's very salty and it will probably have unpleasant consequences, but it's not toxic. The machine can operate right now, is operating with 200 micron nozzle, and you see it's creating a perfect cut. But can operate with different nozzle. I went below 80 microns and you get thinner and more precise cuts. This machine was initially created to create a printed circuit board. And here you see some sample of what I did in the past. I need some light because it's quite difficult for you to see it. But you see, this is a pattern I cut through with this machine. Well, this is another take of the same pattern. This is what it was initially created for, to etch printed circuit board. This is the reason why the software can take directly Gerber files, and Gerber is the standard for electronic CAD. But at the same time, it can do something interesting that is very difficult to do otherwise. Flex PCBs. You know, they're used for wearables a lot. So this is a tiny layer of Kapton tape on which you can engrave a pattern. Well, in this case, it's a Merry Christmas. You can also cut metal. If you insist with time and current, this is a piece of metal as well. We cut it through. This is actually 3 millimeter of copper, full copper. You can cut holes or lines. Also my favorite. Let's see if you can see this one. This is a Vitruvian Man. Oh, it improves this way. Well, it's a Vitruvian Man etched on a full copper board. I'm trying to turn on flashlight. Yeah, and it can, so the device can be used for art. Simply, we took the SVG of this file and etched, well, it was a long etch on a pure copper. Something about the system. Well, the etch is almost finished. It's Raspberry Pi powered, and the Raspberry Pi, with some electronics, generates the voltage and the current needed for the etch, controls the 3D printer through the standard USB port, hosts a website that allows you to control the system remotely, it's finished, and what else? Oh, it generates the G-code necessary for the printer, translating SVG files or Gerber files. I'm also going to bring in raster files possibly. Now, what you are getting? This is a part of a longer project. Eventually, I'm not going to say much about this, but this machine can operate in reverse. It can be used to add metal, to 3D print metal. And I did it. You can 3D print copper with it. But the process is very difficult to control and it requires a longer technical and scientific development. for which I'm going to use the money that you are going to give us, maybe. What you get now is this etcher with some improvement, again, cable management, UI, many other things, and you will tell us what you think needs to be improved. In the meantime, let's see if our etch was successful. Looks like it was to me. Okay, now you should see the pattern. And if I can turn on again the light, yeah, it's on. I show you that it's a cut-through pattern, because you see light shining through the plastic, not through the copper. The black spot you see here is simply because when the pattern closed, the close-by metal oxidized, but it can be cleaned easily. Now, yes, for the first 100 subscribers, I'm going to give you for free all the future hardware and software upgrade for 1 year. So we develop a new box, you get it for free. You just ask, you get it for free. This is handy for us, so we can essentially use you as a beta tester. Thank you for listening, and I hope you will subscribe to our campaign and sustain our journey.